What's up, everybody? It's Your Name back with you for a deep dive into artificial intelligence. AI has been making huge waves, and you know we gotta break it down. We're tracing the evolution of AI through 10 distinct stages. From the first sparks of an idea to the mind-blowing possibilities of the future, we're covering it all. So, if you're ready to explore the past, present, and future of AI, buckle up. Before we had algorithms and datasets, we had ideas. Imagine a time before computers even. Philosophers and thinkers were already grappling with the question, can machines think? These questions laid the groundwork for the field of AI, exploring the very nature of intelligence itself. Could a machine ever mimic human thought? Could it learn, reason, even be creative? What does it even to have artificial intelligence? What would it take to create it? It's the foundation upon which the entire field of AI is built. Fast forward to the mid-20th century, and things start to get really interesting. We're talking about the birth of the digital computer, which changed everything. Suddenly, those big philosophical questions about thinking machines, they weren't so philosophical anymore. Enter the pioneers, the researchers who took those early ideas and started turning them into reality. Think about the 1956 Dartmouth Conference, considered by many to be the birthplace of AI as a field. This is where we see the first AI programs being written, like the Logic Theorist, designed to mimic human problem-solving abilities. These early programs were rudimentary by today's standards, but they were groundbreaking for their time. For the first time, we had machines that could actually process information and make decisions based on logic. This was the era of experimentation, of pushing the boundaries of what computers could do. Moving into the 70s and 80s, AI research took a more practical turn. The focus shifted towards developing systems that could solve real-world problems. This is the era of rule-based systems, also known as expert systems. These systems were designed to capture the knowledge and experience of human experts in a specific field, like medical diagnosis or financial analysis. The program could then take in patient symptoms and, based on the rules it had learned, make diagnoses or recommend treatments. Expert systems were used in fields like manufacturing, finance, and medicine, demonstrating the practical potential of AI. However, these systems were limited by their reliance on explicitly programmed rules. They struggled to adapt to new situations or learn from new data, which ultimately hindered their progress. Chapter 4: Machine Learning, the Data Revolution. As we entered the late 20th century, a new paradigm emerged: machine learning. Instead of programming explicit rules, we started letting machines learn from data. Think about it. Instead of telling a machine exactly how to recognize a cat, we could feed it thousands of images labeled cat and let it figure out the patterns on its own. This data-driven approach unlocked new possibilities. Algorithms could now analyze vast amounts of information, identify complex patterns, and make predictions with increasing accuracy. This was a game-changer for fields like image recognition, speech recognition, and natural language processing. The more data we fed these algorithms, the better they got. It was like teaching a machine to learn in a way that was more analogous to how humans do it. Chapter 5: Deep Learning, Unlocking New Potential. And then came deep learning. Deep learning took the principles of machine learning and supercharged them with artificial neural networks. These networks were inspired by the structure of the human brain, with layers upon layers of interconnected nodes. This allowed them to process information in a fundamentally different way, extracting features and learning representations from data with unprecedented complexity. Deep learning algorithms excelled at tasks that had long stumped traditional AI systems, things like image classification, object detection, and natural language understanding. Deep learning opened up a whole new world of possibilities, pushing the boundaries of what AI could achieve. It's the technology that powers everything from self-driving cars to virtual assistants, and it continues to evolve at an astonishing pace. Chapter 6: Natural Language Processing, AI that Understands You. One of the most significant areas of advancement fueled by deep learning was natural language processing, or NLP. This is all about teaching machines to understand and communicate in human language. Think about it. Language is incredibly complex. It's not just about individual words, but also about grammar, context, and even things like sarcasm and humor. NLP aims to bridge that gap between human communication and machine understanding. We're talking about chatbots that can hold conversations, language models that can generate human-quality text, and real-time translation services that break down language barriers. From virtual assistants like Siri and Alexa to sophisticated language models like GPT-3, NLP is changing the way we interact with technology. Areas like robotics, healthcare, and entertainment. Chapter 8: Autonomous Systems AI in the Driver's Seat. Now let's talk about where AI gets really tangible autonomous systems. These are systems that can operate and make decisions without direct human control, relying on AI to navigate the complexities of the real world. We're talking about self-driving cars that can navigate busy streets, drones that can deliver packages with precision, and robots that can work alongside humans in factories and warehouses. The development of autonomous systems is one of the most exciting and challenging areas of AI research. It has the potential to revolutionize transportation, logistics, manufacturing, and countless other industries. Future of humanity and our relationship with technology. Chapter 10: Superintelligent AI, the future beyond our imagination. Now, let's step into the realm of speculation, into the future that lies beyond even AGI. What happens if we create AI that surpasses human intelligence? AI that can think faster, learn more efficiently, and solve problems at a scale we can barely comprehend. That's the realm of superintelligent AI. Superintelligent AI has the potential to revolutionize our world in ways we can barely imagine. It could solve some of humanity's most pressing problems, from climate change to disease, and unlock new frontiers in science, technology, and beyond. But it also raises profound ethical and existential questions. How do we ensure that superintelligent AI remains aligned with human values? How do we control something that's potentially far more intelligent than we are? The future of AI is full of both promise and uncertainty, and it's a future that we're actively shaping with every line of code we write and every algorithm we develop. Outro: the future of AI, our story to write. And that brings us to the end of our journey through the 10 stages of AI evolution. From the early philosophical musings to the mind-blowing possibilities of the future, we've covered a lot of ground. But this is really just the beginning. AI is a field that's constantly evolving, constantly pushing the boundaries of what's possible. So what do you think the future holds for AI? Let me know your thoughts in the comments below.